Okay, welcome to calculus. This is calculus. I am Scott Grizzard from the University of South Florida. Today we are going to be talking about the min-max functions. This is a little something that we're going to need later. Technically, it should be part of Module 3, but whatever, it never makes it on the test. And I think I'm the only instructor now teaching it. I'm changing a little bit of the layout from last year, so this is kind of a new lecture for me. New, not completely new topic, but a new way of presenting it. So instead of just bearing it somewhere and then, having it not, I'm actually going to do it explicitly. Last time we did L'Hopital's rule, and for an epic fail on my part, I forgot to put the questions on the quiz. Shoot. That doesn't mean they're not on the test. There are 3 L'Hopital's rule questions on the test. I just totally forgot to put them on the quiz. I am sorry about that. The chat for this is, of course, on Discord if you are in my class, and emote-only chat on Twitch. So today we're going to talk about these. We're going to talk about functions with some fancy parameters. And we're going to talk about these functions that are moving left to right. So we've already had some of these functions where they tell you something about charts, like sine, cosine. Sine tells you the northiness about the unit circle. Cosine, of course, sine tells you the northiness. Cosine tells you the eastiness. We're going to look at some more of these, but we're going to have graphs, and then we're going to be asking questions about graphs, and we're going to have functions that tell us information about graphs. A little different. And then we are also going to do, and that's the thing. And then if we get there, we'll start with the AUC function. I'll talk about the test a little bit, et cetera, et cetera. And then next time we will jump right in with the area under the curve. Are there any questions before we get started? Okay. And as I said, I'm sorry about forgetting the L'Hopital's rule questions of the quiz. That was like really bad on my part. So don't be under the impression that they're not on the test. There are. I just, I put a bunch of them on the bootleg, but I just totally forgot. Okay. Any questions, comments, issues, suggestions, thoughts? Okay. So let's go ahead and let's start going over the quiz. So, okay. So here's the quiz. It's got a... got a few questions on it. It starts with a standard type of optimization problem. This one, however, has a little bit of a wrinkle. It's got these things s times l each to the 1/2. This is kind of a standard sort of production function, okay? My corporation's producing jet-propelled pogo sticks. It's got a nice little function. Don't worry about the word Cobb Douglas. Where S is hours of skilled labor working on machines, and L is the number of hours worked by unskilled labor. So if unskilled labor is $9 an hour and skilled labor is paid $36 an hour, what's the cheapest way to produce 100 jet-propelled pogo sticks per week? And what is the per unit cost of that if I do that? So how do we feel about the setup 1 to 5? Kind of the situation that's going on. How do we feel about that? Okay. So there's some confusion on that. Let's talk about that then. Let's talk about the setup here. So what's going on is people are a little confused. So let's talk about this because this is kind of the standard thing. Just like when I'm producing area, here I'm producing something. Okay? So every week I've got a corporation, and that corporation produces these, whatever I want to call them, jet-propelled pogo sticks. Okay? And what the thing is doesn't really matter. The point is that I have some skilled labor and I have some unskilled labor. And I need both to make the thing. Okay? So I've got some skilled people that are working with machines, And then I've got some unskilled people that are working without machines. So you could think of like I'm trying to sew shirts or various levels of machines. Okay. So I'm trying to sew shirts. Now I could have a seamstress sit there with a needle and thread and go on every single one of, every seam on the shirt. Right. I take fabric and I have it doing it. Or I have someone who's a little bit more specialized or, whatever, using a sewing machine. Okay. So I have to pay wages to the skilled labor, the person that knows how to use the sewing machine, and I have to pay kind of rent on my equipment. All right. But even if I have all of the sophisticated sewing machines around, I still need to pay some staff to keep the place clean. Right. I still need to pay some janitorial staff. I'm still going to have to pay for the person who repairs the machines. That's skilled labor. And I have this mix of skilled and unskilled labor. Okay. How do we feel about that? The kind of idea behind the problem that I have this kind of mix of people that are skilled, people that are unskilled. And what I'm going to do is pay them, different wages. But I need a mix. It's not. I can't just have one. I can't have completely skilled labor. I need someone just to go clean the toilet. Now I can pay them more, but I still need someone to clean the toilet, and I still need someone to, bag the shirts at the end of the day. So there's this mix. And if I have no unskilled labor, you can see right here, if I have no unskilled labor, if I only had skilled labor, I would produce nothing. And if I had only unskilled labor, I would produce nothing. So it takes kind of a mix. The joke is, if you've heard about guns versus butter, the joke is that if we all produce guns, that means the cows are making howitzers. No, right? And it's kind of the same idea. I've got kind of a mix of things going on. And I need a mix of skilled, unskilled labor, and just skilled and unskilled. That's kind of a pejorative term, but it's labor that's easily trainable or whatever, and specialized labor, or labor that's working on machines, and labor that's not. Either way, as I said, this is the way that an economist would phrase the problem. And having a master's degree in economics, I tend to phrase things this way. So how do we feel now about the setup? This kind of idea that I'm going to produce some amount, and I want to know what the minimum cost is for producing the $1,000 of jet-propelled pogo sticks per week. Okay. So we feel a little better about the situation. That's what it seems to be. Somewhat. Now, the idea is that I have this output function, right? My quantity output is equal to the skilled labor times to the 1/2 power to the 0.5, or the square root of skilled times the square root of unskilled. So what I do is I have quantity, and that needs to equal 1,000, and that equals S to the 1/2 L to the 1/2. And then I have my cost function, right? I need to pay my unskilled labor $9 an hour. Okay. So it's 9 times L. And then skilled labor costs $36 per hour. And when I say paid, I mean including benefits and everything. The employer's half of Social Security, the unemployment benefits, what it costs the employer to employ you for an hour. Okay. Which is I don't care what you actually get in your paycheck. I mean, I do care, but, from a standpoint of maximizing my profit, it's not the amount that you get in your paycheck. It's the amount that it actually costs me to employ you. So this idea that you only pay half your Social Security and your employer pays the other half is crap. You're paying the whole thing, just so you know. Because your employer sets their wage based on, your marginal productivity, based on what it costs you, and you get what's left over to take home with you. Okay. So that's kind of the situation. So what I do is I have these two equations, and I'm going to minimize costs subject to the fact that I need to produce 1,000 units. So I'm going to take this constraint, and this constraint, 1,000, is really just 10 to the third. I'm going to put things, because these are big numbers, I'm going to put them in exponential form just because they're easier to deal with. So this is really, and then I'm going to square everything. So I'm going to take this 10 cubed and square it, and I'm going to wind up with s times L on this side, right? Because I've got 1,000 or 10 cubed equals s to the 1/2 L to the 1/2. I square everything, and I wind up with 10 cubed squared equals s times L. How do we feel about that, 1 to 5? This idea of getting one equation, the dealing with the constraint. The constraint here is output. Okay. And then I'm going to solve for s over here. And I solve for one of the variables, and I get that s equals 10 to the 6th over L. I could write out 6 zeros, I just don't feel like it. Which means that the cost equals, when I substitute this equation here in for this equation, right, for that 36s, I wind up with 9L plus 36 times 10 to the 6th over L. And I work out this a bit because I know I'm about to take a derivative. I wind up with 9L plus 36 times 10 to the 6th times L to the -1. Okay. So how do I feel that? Getting one equation with one unknown. How do we feel about that? 1 to 5. Or one equation using only one of the variables. Combining the two equations to get that. 1 to 5. How do we feel about that combining bit? Okay. All right, so what I'm going to do is I'm going to take the derivative, I'm going to set it equal to 0. So the derivative of c is 9, right? The L goes away. 9 minus 36 times 10 to the 6th. This is just a constant, but it's being multiplied by this L to the -1, so it hangs out. It doesn't go away. I get a minus sign because I'm taking that -1 here, and I'm bringing it down in front, and then this becomes a -2. And then because I'm optimizing, I'm going to set that equal to 0. How do we feel about just this piece right here? Taking the derivative and setting it equal to 0. Okay. So after I do that, I take the derivative, I set it equal to 0. I get these equations right here, right? This, I move the 9, I move this bit over to the right side and rewrite it so that the L squared's on the bottom instead of an L -2. I multiply both sides by the L squared and I divide both sides by the 9 and I get this. So I wind up with the fact that L squared is going to equal 4 times 10 to the 6th. And then I square root both sides. 4 is a nice number to take a square root of. So I wind up with 2. This is, so L to the -1 was the initial, and then when I take the derivative, the -1 comes up in front by the power rule, and then I subtract 1. So this becomes L to the -1 minus 1, which is -2. Okay. Question was, how did I get this L to the -2? And the answer was the power rule when I took the derivative. Do a bunch of algebra, and I wind up with this. So I solve for that, and I get 2 times 10 cubed, or 2,000 hours on there. So the -1 goes, the -1 is created here when I take this, right? So the -1 hits this 36. The 9 is positive. I move this over to the right side, and that's the thing that makes it positive, right? Here it's negative, and then I add the 36 times 10 to the 6th to both sides. Um, and since I do that, that's how I get those numbers. So that -1 goes with that other thing. So I wind up with 2,000 hours here, and then I use my this equation right here, and the 10 to the 6th and the 10 to the 3rds cancel very nicely, and I wind up with 10 cubed over 2, which is 500. So I wind up with 500 hours of scaled labor. How do we feel about getting those two numbers, 1 to 5? Okay. All right, now I'm going to take these two numbers. Well, first thing I'm going to do is I'm going to do a second derivative test. So I take the second derivative of this thing right here. I take the derivative of this thing, which would be the second derivative. And I wind up with 2 times 36 times 10 to the 6 times L to the -3rd. And I don't care anything about that except that it's a positive number. Okay? So I know I found the minimum, whatever it is. And then, so when I put that through, I insert my L and my S here, and I wind up with $36,000 for as total cost, which gives me a per unit cost of $36,000. So I write this little statement about what I meant. So 1 to 5, how do we feel about the second derivative test? Just the second derivative test there. Okay. And then you add these things and you wind up with 36,000. Now, let me check to make sure I answered all the questions. What is the minimum cost? I have it, 36,000. And what is the per unit cost? I have it, $36, right? I divided by the 1,000. I also said the 500 skilled and 2,000 hours of unskilled. I didn't have to, right? I didn't have to because that wasn't part of the question. Now, the question could have asked for that mix, in which case I needed it. But here the question didn't ask for it. So if my final answer doesn't include that, that's fine. Okay? All right, so are there any questions here? So questions. I got the 36,000 and the 36, but I didn't break it down into skilled and unskilled. Oh, I just answered that. Perfect. Can I use the first derivative test? Yes, you can. What the second derivative test gave me a maximum. If the second derivative test gave me a negative number. Yes, so if the second derivative test wound up with a negative number, I would be concave. Let's see. I would be concave down, right? And that would have given me a maximum. But here, the second derivative test, I was concave up. That means I found the minimum. The words, let's see. Per week. Yes, so I actually probably should. So the total cost is $36,000 per week. And the 500 skilled things of 36. Yes, I probably should have said the per week. But I wouldn't have counted off. People might have. But that's okay. These are slightly confusing problems. Again, like the related rates, these are a bit of reading comprehension problems. So the idea was I have weekly production costs, and part of the skill is knowing what to ignore and what not to ignore. Okay, are there any other questions? So 1 to 5, how do we feel about this problem now that it's been explained? There's still some 4s and some 3s, and uh, there's a one or a few ones. I'll be happy to go over it in office hours. Remember the test review today at 5 p.m. I will be happy to go over optimization problems until the cows come home. I know they're a little confusing, and they're tough problems. Like the related rates, they're tough problems. So we will talk about them. Okay, let's move on to question 2. As long as there are no more specific questions. This one was one of the harder graphs. Wasn't the hardest one we've done. But the key is to keep track of the conditions. So the way I did it was I did the stuff that's in dark purple first. So the first thing I did, I saw this was here. I put that little arrow there. I read this from -1 negative infinity to 0, I'm decreasing. So I put these little arrows here, and I said smoothly because it's a derivative condition. I can't have any kinks and stuff in this until I get to the interval 0. Now, and then I had another decreasing condition, which was right here. Now, I knew that f double prime had to be less than 0. That's concave down. So I put everywhere where it had to be concave down. From 0 to 4, I made these little frown faces here. And so I'll get to the others in a moment. F prime of 0 doesn't exist. I know there's got to be a kink at x equals 0, or a discontinuity. And I could have done a discontinuity because I didn't say, I did say continuous. That's kind of a mad little hidden function. I wish I had put that down here. Sorry about that. I did say continuous though, so it did have to be that. Now, the limit as x goes to infinity had to be -2, so I put that there. F double prime had to be greater than 0, so I put that here for 4 to infinity. And f prime of 2 had to be 0, so I know there had to be a min or a max there. Now, when I was looking at this, I put my little min-max note here, but notice here it's concave down. That means I have to have a max. 1 to 5, how do we feel about that? The fact that the derivative was 0 here, but the thing had to be concave down meant I had a max. So once I had my notes, I ignored this stuff now, and I wrote these things, and I wrote my line here. So my line I wrote was a straight line from here to here would do it, right? Derivative defined. I could have done something different. I could have had it come like this. I could have had it come like this. All of those would work as long as it was always decreasing. So I just did a straight line. Why not? But as I said, I could have done something else. And then I needed a kink here, so I just wrote kink, and I went, and then I just came up, and I made sure I was concave down, and I just came up to about here, made sure my local max was here, and I came back down. Now, notice here I changed inflection. So here I was very clear, and I actually started here, and I went up like this, and then I started here, and I kind of came down, and I kind of worked at it until I made them meet. And then I labeled everything. And labeling everything in green is optional. Okay? But I just wanted to tell the grader that I knew what I was doing. So I labeled everything in green. I wrote kink here. I wrote a local max there, and I drew a little, horizontal line, tangent line. I said that there was an inflection point here, and I tried to draw a tangent line here. I didn't quite succeed. That was below on one and above on the other. This one should have actually been, the tangent line should have been more like this. To show on one side it was above and one side below. Make sure it's smooth, and then let's draw a new tangent line. There we go. So on one side, the tangent line is below, and on the other side, the tangent line is above. Totally optional. You didn't have to draw that. But I set a inflection point there, and then I set a horizontal asymptote here. 1 to 5, how do we feel about this graph? This one's a little involved. Okay. All right. So we're feeling a little bit more comfortable with the graphs. That makes me happy. Are there any questions about this? Comments, issues, suggestions, or thoughts? And yes, there was another way to do question 1. There's the other way. If you don't understand what that means, don't worry about it. That was the stuff I did yesterday in class. In the thing. Finding the inflection point on a first derivative graph. Do you mean the ones where I give you the graph and you find the inflection points? Okay. So that would be, if I'm looking at the graph of the first derivative, that would be the maximums and the minimums of the first derivative, right? Because that's where the slopes changed from increasing to decreasing. As opposed to here. See how here the slopes went from decreasing to increasing? And then if I had the graph of the derivative, that's how I would check. And if you want to, I'll derail the class just a little bit to show that. Right, so here's where the inflection point is. This is the graph of the derivative. And this is where an inflection point is, because here I've got a local min of the first derivative. Okay, here, again, this is the derivative. So my slopes are decreasing here and increasing here because this is the derivative. So here my f prime is decreasing, here f prime is increasing. And that means that right here, I've got an inflection point because the derivative went from decreasing to increasing, which is the slopes of the tangent lines of f. Again, this is f prime, not f itself. But the concavity of the concavity, so the question is, the concavity also changes at 0. Yes, the concavity of f prime changes, but not the concavity of f. Remember, I'm talking about the concavity of f, which is fine. It's okay. Right here, the concavity is always still decreasing. Right here, the slope, the derivative is always decreasing. That means f had that. Yes. Okay. And there's the other way that I talked about last night. All right. Let me talk about the test for a little bit because I know everybody's kind of urgent about that. This concludes the material for the test, this quiz. And yes, I will post the key. So I just blew by the other way, I know. Let me talk about the test for a moment. So the way this is going to work, and you'll see that on Saturday morning. And bear in mind, it has to be done on Saturday morning unless you've made, it's just like a regular live test. What we've decided to do is set up extra time. So you're going to have 90 minutes to take the exam proper. And then you're going to have another 15 minutes to make sure everything's uploaded properly. And then what you're going to do is you're going to join Discord. Now, you're going to put on Discord on your phone. So make sure you've got the app on your phone. Because what we're going to do is we're going to all have Discord open on our phones. And our phone's sitting right here. Okay? And what's going to happen is that I'm going to make announcements on Discord. We're all going to join the same voice chat. Now, if you have a question, you're going to pick up your phone and you're going to move to a raised hand channel. Okay? So if you're on Discord right now, the thing is going to look like this. I'm going to create a voice channel, and it's going to say test taking. And this is going to be for everybody that's taking the test. You can see the voice channel. I can't show the Discord on Twitch because your names are on it. So if you switch to Discord, does everyone see the voice channel called test taking? And then there's going to be another channel with the exact same privileges that says raised hand. Okay? There will also be another channel called special test taking. Okay? But you won't be able to see that channel. Okay? The only people that will be in the special test taking, so now you can see it, and now you can't. The only people that will be in this space, and I hope what you're doing is testing the thing out, because obviously I'm in chat right now, so I can't answer your question and listen to your thing. But the special test taking channel, which you now can't see, is for people that had issues, have SDS accommodations, have some kind of or arrange something with me ahead of time, and for some reason they aren't ending at the exact same time that everybody else is ending. And again, these could be SDS accommodations, these could be technical issues, these could be prearranged with me. For instance, my internet doesn't open until 10 a.m. for some unknown reason. And then there are these special channels. Okay, so that's the idea. So 1 to 5, how do we feel about the way that the test is going to work on Discord? Can I get a 1 to 5, please? Oh, there we go. Okay. And just as a reminder, we are in the 9:30 a.m. chat. All right. And then what's going to happen? So, and yes, this will all be posted everywhere. Now, the camera is going to be your normal webcam, either on your laptop or whatever it is. Hopefully the thing can see all of your workspace, but if it can't, we'll work around it. The important thing is that at the beginning you show your workspace. Now, I don't want you stressed about Proctorio, okay? Proctorio is there to kind of give some assurance of integrity, but don't be super stressed about it, okay? If you're being honest about taking your test, you're not going to have anything to worry about when it comes to Proctorio, all right? If you're trying to cheat, then you have to worry. But if it was up to me, we'd all sign honor statements, and that would be the end of it. But it's not up to me. This is a coordinated class, and I have to go with the flow. So we all decided to use Proctorio. That's what we're going to do. Well, actually, if it was up to me, I'd give you a test that was take-home, open note, and just tell you can't collaborate. And then, I trust you not to collaborate. You sign an honor statement, but I'd give you a test that was designed to be a take-home. But I can't do that because we've got other instructors, and this is just how we've decided to do it. So yes, so you're going to have little issues with Proctorio and things like that. Okay. Now, are there any other questions about that? So there's going to be a quiz, just like you've done the quizzes right now. Now, apparently I've had the settings wrong on Proctorio. I'm also supposed to be recording your screens, and I wasn't. So I need to fix the settings on Proctorio. But it's going to be a quiz, just like you normally have the quiz. And it's just going to be like the quiz. The big exception is that you need to either print out or have your notes, blank sheets of paper. Well, not blank. You need to fill out. You need to print out the original the task answer sheet, or you need to take the test the blank sheets of paper and create your own answer sheet. and there is an assignment on the uh, on the there's an assignment online right now, a pre-assignment that tells you where to go for that. That tells you exactly what to do. And that pre-assignment is due Thursday night, and it's a test run for uploading the entire test to Gradescope. So what you're going to do is you're going to print out your answer sheet. You're going to sign your name, or sorry, not sign your name. Write your name, write your section number, and then you're going to take all of the pages of the answer sheet and you're going to upload them to Gradescope. However you get it done. Now, there's some question about the phone. There's two reasons to have the phone open on your, to have Discord open on your phone and not on the computer. The first is that it's going to make Proctorio mad. The second is that the phone is where you're going to go if you suddenly have technical issues with your computer. Okay? So, if we have technical issues with the computer, okay, you're going to be on your phone, which hopefully has a 4G connection to the internet that is separate than your home internet connection. So the idea is that if you have trouble, you can raise your hand on the phone, I can talk to you, while we're doing it, and then we can fix the problem. You might get, a little bit of extra time to deal with the technical issues. And whatever it is, but the point is that if it's on your phone, it's separate from you taking the test. Okay? Are there any other questions about that? That's the logic of the phone. The logic of doing Discord on the phone is that it's separate from your internet connection at home. Yes, you may be connected to Wi-Fi over your phone, but the point is that if your Wi-Fi cuts out, the phone will be able to reconnect with 3G. You can raise your hand, jump in the raise your hand chat and say, Scott, my phone isn't working. Okay. And then let's see. Are there any other questions? Bootleg submissions. Yes, you can use blank sheets for the bootleg submissions. Remember, they have to be the exact same number of pages, though. So when you do your bootleg submission, if you have blank pages, make sure that you copy it over. Have the professors talked about possibly curving the exam? We have not talked about that. We have resisted it, but what happens will happen. I think it's highly unlikely that the exam will get curved. It's more likely that if the thing is a disaster, the final exam, which replaces your lowest test score anyway, will become easier. But we don't want to curve exams if we can possibly avoid it. But I'm not as worried about you guys as I am some of the other classes. I've been watching you guys. Most of you are keeping up with the class. There's a reason why you're turning in your notes. I've been looking at it. You're having the same difficulty that about the same level of difficulty and about the same level of questions as it was during a normal semester. So I'm actually less worried about that than I'm actually less worried about you guys than I am some of the other sections. Now, there's another question. What happens if we live in a dead zone and our Wi-Fi cuts and we don't have either 4G or 3G either? If that's the case, please talk to me about it ahead of time. If you know you live in a dead zone, I live in a dead zone for 4G. I've actually tried. One time I bought one of those antenna things to repeat, and then they changed then we changed cell phone companies. But if you do live in a dead zone, email me ahead of time. Let's talk about it. Maybe there's another place you can take the exam, or we'll arrange it ahead of time. But arranging things ahead of time is very, very important, because then we've got contingencies to deal with these things. Are there any other questions? And internet outages happen. Hopefully at 9:30 on 9 a.m. on a Saturday, it's not a big deal. But that doesn't mean that it won't happen. And I don't want you to be stressed and worried about that. I want you to be a little bit stressed and worried about the test itself and not about all these other issues. Does that answer all your questions? Are there any other questions about the way this is going to work? Okay, so you're going to download and print the answer sheet ahead of time. You can see it here. And of course, you've got all these other things. Now, be sure that when you go, be sure that you get next Thursday. That's due Thursday. Nope, 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 nope. Sorry, mine doesn't work the same way yours does. It just lists everything. There it is. So make sure before Thursday that you do this test prep. You have to get the test sheet advanced thing. Now, also on here, we're also going to release, the way that we're going to release the test is it's going to be linked in a private URL. So if you clicked on that URL beforehand, if you managed to find it, it would say, I'll show you exactly what it says, right? It says not here. So it says this is where the test will be. So if you really want to see what it currently says, if you manage to find the URL that, if you manage to find the URL, it would say this right now, right? This is where the link is going to be for the test, okay? So if you manage to find it, all you would see is this, test 3 will be posted here. The idea was that we've got all these instructors and we didn't want one to accidentally post the actual link to the test or before the actual test, because I don't want to write another one like I had to for a different test. And we won't talk about that anymore. We won't talk about the person who posted the test ahead of time. So, and that's why it's set up like it is. You'll have, this is the pre-assignment. Make sure you get it done. Any other questions, comments, issues, suggestions, thoughts? Okay. If you pull up the answer sheet, okay. If you pull up the answer sheet, you'll actually see what's going on here. The answer sheet changed, of course, yesterday. They couldn't help themselves. They changed some things on the point distribution. So this is now worth 9 instead of 8. If you've already printed your answer sheet, that's fine. Just take a little pen and scratch the points and make sure they match up. But you can see now this is now worth more points. This is worth the same. This is now worth 4 points. You can now guess exactly what problem that is. This is worth the same. This is worth the same. And we robbed the true and false questions of points in order to pay these. The proof is still, some instructors are like, well, let's put the proof back on. No, I actually voted against that. Believe it or not, I'm pro the proof, but, at this point, we've already made enough changes. I was like, no. True, false are fine. So that got voted down, thank goodness. But and then there's still the 2 graph questions. Each one's worth 8 points now instead of 10. Any other questions about the test? And I'll be going over all of this stuff when I go over the at test review tonight and on Thursday night. Any other questions? How do we feel about what's about to happen about the test? I mean, confusion-wise, how do we feel? Review tonight is at 5 p.m. and 7 p.m. tomorrow. So how do we feel 1 to 5 about the test and how it's going to work? And how do we feel about the fact that I am not out to get you on Proctoria, right? I'm trying to make this as like being in the test as possible. Okay, so I just want to know how you feel about the procedure. What's going to, and how you feel this idea that I'm not out to get you. I'm trying to make it just like it was. I'm going to, not be able to do that, but I am. Okay. So today at 5, it'll be a test review session. So you could ask me questions about the problem set. You could ask me questions about the bootleg. You can ask me questions about any of the quizzes. You could ask me questions about any of the web assigns, anything you want to ask me. All right. It's like the test reviews always are. The only difference is that you don't have to take the bootleg in the test review, right? Because the bootleg is now proctorioed, so you can take it whenever you want to, and you can take it up to 3 times. Any other questions? All right. So let's get into what we actually wanted to talk about today. Again, this is stuff that's technically in Module 3. Now, let me give you some motivation for this. How many people, raise your, seen The Hunt for Red October? Okay, so, have you seen The Hunt for Red October? Let's see, I need to do a yes-no poll. Hunt for Red October. Did that work? Yes. Okay, so, yes, the movie, the submarine movie. We've seen it. This is sad. Okay. All right, everybody, your homework assignment for today, go watch The Hunt for Red October. When I was young, okay, the film came out in 1990, okay? When I was a teenager, or whatever, we won't talk about how old I was then, this was the 5th coolest movie I'd ever seen, okay? There's, of course, for my generation, there's the Holy Trilogy, Star Wars, Empire Strikes Back, Return of the Jedi. Then there was Top Gun. And then there was a submarine movie called The Hunt for Red October. Now, if you ever read the book, the ending for the book and the ending of the movie are slightly different. The book there are 2 major plot lines. There are 2 major suspense lines. There's the KGB officer in the submarine that's, defecting or whatever. And then there's the Akula-class submarine that's hunting them, the Russian sub, okay? Now, in the novel, these 2 things are resolved separately, and it just doesn't quite work. I mean, it worked enough to make a really cool movie out of it, but Clancy's novel doesn't quite work in this sense. And he got better at it, but he wasn't really the master. He was great at creating suspense, but he wasn't the master at resolving it. Well, the screenwriters went back, if you want to kill us, Ferguson and Stewart, Larry Ferguson and Donald Stewart, who died recently. When they went back, they resolved both at the same time, okay? And it makes the thing just so much better. As an aesthetic thing, resolving both of these issues at the exact same time made the movie like so much better than the book, right? It's one of those few where the movie was better than the book. This is the same thing. So has everyone had that experience where something just wasn't quite resolved right? The fundamental theorem of calculus is the thing we're moving toward, okay? And it's probably one of the most beautiful proofs in mathematics. And it is beautiful, but there's this issue with it, where you're kind of like, and you have to spend all this time on this detail, okay? So what I want to do is I want to talk about this detail that's in the fundamental theorem of calculus. We need to resolve it now because that makes the whole thing so much tighter and more beautiful at the end. And there's another reason for doing this because it's actually this is the time to present the information, not when you do the fundamental theorem of calculus. Now is the time to talk about this thing called the max function. Okay. Because if you do it when you do it at the fundamental theorem of calculus, it just kind of buggers. The other thing is the first real function we have with a parameter. I mean, we kind of saw some before. Let's talk about this thing. It's kind of enough intro. Let's talk about this thing. I got 20 minutes left to do it. People are asking questions in chat right now about the bootleg and everything. I will be happy to answer those, but not in class. I want to actually get to this part of the thing. So those questions I will answer to your heart's consent, but I will not answer them now. Okay. So let's talk about this function. The max function is as follows. So let f be a continuous function. I don't care what D is. It could be an open interval. It could be a closed interval. I don't care. It could be half open, half closed. Don't care. Just some interval D. The fact that it's an interval is what's important, not the fact that it's, open, closed. Don't care. All right. And it has to be continuous. So the things that are important here is that f is that this function is continuous over some interval. And then let a be some point in the interval. Now, I'm going to define a new function about f. All right? F is not the function. F already exists. Now I'm defining a new function about f. And it's called the max function. It looks like this. So max f a, these are the parameters. Of x equals the maximum of f of t, where t is in the interval ax, if x is greater than a, and max f of t, so that t is in the interval xa, if x is less than a. Whoa. What the heck is that? Kind of weird, right? Let's look at an example. Let's look at the function, something like, let's look at an example. Let's look at f of x equals, let me write example in a different color. Let's look at f of x equals x cubed minus x squared. Let's do minus 2x squared, otherwise it's just ugly. All right, so let's look at this function here. So here is, come here. Here is this function, all right? This is what this looks like. This function looks like here. What we'll do is we'll just take a little snip of that. Let's do a little screen snip of that and drag that over here. All right. Now, on our example here, let's let a equal 1. No, let's let a equal 0. So a is in the domain. And this thing's continuous on infinity, infinity. So we'll call d equals infinity, negative infinity, positive infinity. All right, now, question. What is max? If A equals 0, what is max F0 of 0.5? What do we think? Yes, the question is, what's the spot? Okay, so what is F of 0.5? F of 0.5 here, which is bigger, F of 0.5 or something else in the middle? The question is, what is the max, right, of A what is the maximum of f of t if t is in 0.5? That's what this is asking. Yeah, it's 0, right? It's not here, it's here. Right? Indeed, this max function all the way through here does nothing, right? It's this. Then when I hit 2, what happens to it? What is the maximum? What is max F0 of 2.1? What is the maximum? In other words, what is the max of f of t if t is in 0, 2.1? How do I make this go away? No, it's not 0 anymore. If x is 2.1, it's bigger than this, isn't it? So my max function, when I go along, is 0, 0, 0, 0, 0, but it hits this 2, and then it starts increasing. Right? It's bigger than 0. Now, to the left, what's going to happen? If this is here, right, what is the max of negative 0.5? So what is max F0 of negative 0.5? So I use now the other side of my definition, right? Negative 0.5 is here, but A is 0. So this question is asking, what is the max of F on negative 0.5, 0? Right? Well, this right here is less than 0. It's less than f of 0. So this is still going to be right here. How do we feel about that 1 to 5? This is weird. And I'm not saying it's not weird. That's why I'm starting it now, instead of dealing with this while we're trying to deal with the rest of the proof. Okay? I'm trying to deal with this now. I'm trying to break up what's really confusing from what's really beautiful and get at this. Okay. I understand. So let's do it again. Let's do a different one. There's also a function called min. And that is defined as the minimum of f of t, so that t is in ax. Oops. If x is greater than or equal to a, and the min of f of t if t is in xa, if x is less than a. So I have the exact same question, but now my question is, what is min of negative 0.5 of f0 if my base point is still the same? What is smaller? What's the smallest value? This asks what's the smallest value on this interval? What is the smallest y value on this interval? This one asks what's the biggest Here I'm asking for the smallest. Yeah. So the smallest is like negative 6.5 or whatever, right? But that's the output of this function. It's that point right there. It's not this, right? It's not this point. It's not this y value. It's not this y value. It's not, right? It's that y value there. It's not this y value. It's not this y value. Why is that thing up? It's not this y value. It's not this y value. I want to send this to the back, don't I? So it stops doing that. Okay. It's not this y value. It's not that y value. All right? It's this one right here. Now, if I trace this function like I did before, I'm going to get right here. If I'm here, this is smaller than that, right? So as x moves to the right, this function increases when it gets here. Now, I go off to the other side. Now I'm asking the other question, what is the minimum on this interval? And the minimum on that interval is this one. So as I go to the right, as I go away from my base point, 0, I'm decreasing. Now, what happens when I get to this point here? What happens when I get to this point right here? Well, here's my minimum on that interval, isn't it? So when I get to this point right here, what happens when I get to this point right here? Right, you're changing from decreasing to increasing. In other words, the minimum has stopped. The global minimum on this function, right, the global minimum is here. So now, as I go to the right, It's going to be that minimum. Bring you up just a little bit. Now my min function is just defined as that minimum, right? So now the function, the minimum function, is increasing and increasing, and then it comes back down, right? Because each one of these is the smallest thing on this interval. But now, if I'm asking for what's the smallest value of the function from 0 to 2, it's right here. So it becomes down, and then it becomes the constant function again. How do we feel about this one, 1 to 5, the minimum function? Right. Okay. Let's see what happens when I change the base point. Okay, let's change the base point. Same function. Oops. Delete. Exact same function. Exact same interval. But let's change the base point. You know, as an aside, I really like the idea that I could copy and paste on that. I can't do this on the blackboard, right? On the blackboard, I can't go, okay, I want to copy this and I want to paste this, but I want to change this line, right? I mean, that's just incredible. And I can paste things instead of having to trace them. I really like this. What do you think? Do you like this better than the, there's a poll. Do you prefer this, the Twitch, or the classroom? Which do you think works better for learning? Which do you prefer? Because I'm really starting to like this, right? I got the 5 poll here, right? So let's ask that as a poll there. Poll, Twitch, or class. Let's see. Thumbs up for Twitch, thumbs down for class. Okay. All right, well, okay, so the class is better. I'm just saying, from my point of view, the Twitch is nice because, I could, copy and paste and stuff, but I can see the point. Yes, okay. So we prefer the in-class. Noted for future reference. Yeah, there are pros and cons of both. Yeah, I hate that room, though. So the comment is I could use this and project. That is absolutely true. But that would work in some of the larger classrooms with nice bulletin boards. It doesn't really work in that classroom because there's just not enough space. So I don't like it for that one, for that classroom. But for the lecture halls, yes. There's one in particular that I really like, which is the lecture hall in the ROTC building, because it's nice for that. Anyway, I got 5 minutes left, so let's do another example. So let's let a equal 1. All right, now, if my base point is 1, here my base point was 0. Oh, let's change the colors here. Let's let my base point be 1. Here my base point was 0. Now, same question. Let's talk about which one blue is. So blue was max, and kind of purplish was thing. So the max function. So what is the max of what is the max of 2? Okay, so what is max f1 of 2? Well, it doesn't also shift to the right one. This is actually interesting. What is the max on this interval? From 0 to 2, from 1 to 2, what is the max? Is the max from 1 to 2, is the max here? Right, the max is way up here. The max for 2 is way up there. What about for 1.5? Well, for 1.5, the max is actually -1 over that interval. So I've got this interesting thing that happens. Here, the max is going to be something like this. But then when I hit this point, it starts going up again. There's the max function. Well, what about on the left side? On the left side, my max function is going to look like this. I don't want it to be like that. But then when I hit -1, it goes like this. Right, because the -1 at that base point is bigger. No, here I am. Sorry about that. When I hit the max, it's not -1 where it happens. It happens at 0, right? Because that's biggest. Now, when I hit 0, that's the biggest point, right? So I go flat, then decreasing, and then here it's like this. Let's look at what the min function does. The min, as I go to the left, is going to be here, 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 here. But then again, when I hit this minimum value, it just goes over. Look here, the minimum is this, until I hit this point, and then it goes down again. So the question is, do I need the graph to do this? Okay, and the answer is, I kind of need the graph to do this. Okay, I'm not going to ask you to do it algebraically. The important piece is a couple of conceptions about this. Okay, does that answer your question? I'm not, if I ask you a question like this, and again, I'm not going to ask it on the test, but I may ask you on a quiz in the future. I'm going to actually ask you, I'm going to give you the graph and ask you to trace it, because that's actually more important. The concept is the important part. And there are a couple quick things about this. I know I'm out of time. There are a couple of things about this. Okay. Both max fa of x and min fa, it shouldn't be fa, are well defined Why is this true? Why is this true? Why are both of these true? By what theorem do I know that this thing is actually well defined? It's not just that it's continuous, but I'll talk about the continuity together. But what theorem tells me because f is continuous? Yep, the EVT there, the extreme value theorem applies. Okay. Another second thing about this. Max f of a Okay. The other thing that's important about this is that both of these functions are continuous functions. Okay. So, and you can see that from the graph here. I've got two continuous functions. This blue line here is continuous, and this purple line here is continuous. Same thing here. This is continuous, and this is continuous. It's not differentiable everywhere. It doesn't have to be differentiable, but it is continuous. Okay? So how do we feel 1 to 5 about those two properties? That it's defined everywhere and it's continuous everywhere. Okay. All right. I am out of time. We did not get to everything that I wanted to today, but that's fine. We will pick up next time with the area under the curve function, which I have nice graphics for, which will really help. So again, last time we went over L'Hopital's rule, and I did an epic fail because I forgot to put them on the quiz. Today we talked about the test a lot, and then we talked about these functions with fancy parameters, the minimum and maximum functions, and the fact that they both exist. They are both well defined because of the EVT, and they're both themselves continuous functions. Okay? I'll be in Discord chat if you have any questions.